let's prove the following for all n. This multiplication from n plus 1 to 2n is equal to 2 to the power n, and product of all odd numbers. This is true for all n. Very interesting identity. So for example, if I say n is equal to 1, if I start with n is equal to 1, so that would be if I put here to 1, and then it should go up to 2 times 2. So that's on this side. I'll just have like 2, and then 2 to the power 1 multiplied to all odd numbers is this, just this one, 2 is 2. So if I do n is equal to, say, 3, so that would be more interesting. So 3 plus 1, I would start with 4, 5, 6, up to the twice of that number is equal to 2 cubed multiplied by all odd numbers. Right, so that gives me, this part is 15 times 6, 90, and then this one is 120, because this is 15 times 8, 120, and then this one is also 120, so they are equal. So how do we prove this using induction? So to make it easier to use the induction, we can rewrite the expression and do the following. Let's say the product Pn is equal to the product of all numbers from n plus 1 to 2n over 2n and product of all odd numbers. And then we want to prove that this Pn is equal to 1 for all n natural numbers. All right, so now we have the expression. On one side of the expression, we have constant number always. So this expression has to be equal to 1. So the base case is obvious. So let me assume that pk is equal to 1. Now I want to prove that pk plus 1 is equal to 1 as well. So the step of induction. So the expression for pk plus 1, what is the expression for pk plus 1? It starts with k plus 2, so the next number after k plus 1, and goes up to 2k plus 1 and 2k plus 2, right, up to the 2k plus 1, the twice that number, and over 2 to the power k plus 1 multiplied by all odd numbers. So 1, 3, 5, up to, so 2k minus 1 is odd, and then 2k plus 1. So now let's look at the expression, closely look at the expression. This 2k plus 1 and then this 2k plus 1, they are actually equal to each other. So I can just cancel them out. So when I try to simplify my expression, right? So I will cancel out only those two. And then look at this 2k plus 1. So that 2k plus 2, so the 2k plus 2, that's equal to 2 times k plus 1, right? So if I bring this k plus 1 here to the front and then cancel this 2 with one of the 2's here, I will just have the product starting from k plus 1 up to 2k, right? Because 2k plus 1 is cancelled out. The 2k plus 2 is k plus 1 is here, 2 is cancelled out. On the bottom, I have 2k multiplied by 1, 3, 5, up to 2k minus 1, because we don't have 2k plus 1, it's cancelled out. And this expression is just pk, the expression for pk, which is 1. So pk plus 1 is equal to pk, and they are both of them are equal to 1, because if we assume pk is 1, then pk plus 1 is also 1.